Here I want to play around with standard deviation. So I started some summary statistics along with a histogram of ages of my students over the last few years. So I'm going to continue to play with this, and I'm going to throw in some other summary statistics. So I used the min, max, and range earlier because I needed those numbers to think about how to design my histogram. I'm going to move, those out of the way. And here we're going to worry about standard deviation or work on standard deviation. Now, standard deviation is a measure of the average spread of the numbers from the mean. So before I calculate the standard deviation, I should calculate the mean. Do I have to? No, the computer can totally do it. So I'm going to put a spot for mean and standard deviation. And again, we can calculate the standard deviation without finding the mean. So if I just start typing STD, we want the standard deviation of a sample, which is the .s1, and then we select the data, close the parentheses, enter. So standard deviation is a little over 9. I'm going to cut that down to 1 decimal place. Usually we take calculations to 1 more decimal place than the data. And here everybody had whole number ages. So I'm going to say the standard deviation is about 9.3 years. Now again, standard deviation is an average measure of spread from the mean, so standard deviation is not meaningful unless we have the mean, or the average. So I'm going to start getting average here. I want the average of values, select the data, close the parentheses, and so the average age was about 26, if I take that to 1 decimal place. Oops. So just for fun, I'm just going to say the average age is again about 26, and the standard deviation is about 9 years, let's say, to no decimal places. So what I want to do is I want to consider, well, where is 26 here? So 26 is about there. And let's make a copy of this to draw on and get a drawing of it. And let's paste it unlinked. Linked versus unlinked. Linked means the drawing will update if you change the data or the chart somehow. Unlinked means it's just a picture of it. It won't update. All right. So what I'm going to do is I'm going to get, let's say, a pen here. Let's make it red. And I want my scribbler. And I want to make a mark at about where 26 is. So that'd be about there-ish. And oops, I lost my color. Let's make it red and a little thicker. All right, so that's about where the mean is. And then the standard deviation says jump 9 to either side for 1 standard deviation from the mean. And again, standard deviation has to go with the mean. So the number 9 on its own is meaningless. So 26 plus 9 is going to take me to 35. So that would be 1 standard deviation away from the mean. And then I can do it again. 35 plus 9 would be 44. So that'd be somewhere over here. So that'd be 2 standard deviations from the mean. We can go the other way too. So 26 minus 9 is going to put me at 17. It's going to be about right here. So that'd be 1 standard deviation below the mean. If I do it again, minus 9 is going to put me at about 8, which is somewhere off the chart over here. All right. So again, this is my mean right here, x bar. Didn't like that. Come on, put a bar there. Okay. And then here I counted 1 standard deviation to the right. So that would be x bar plus s. S being standard deviation. And then over here would be x bar plus 2s. Right? So we took x bar, that was our 26 for the median, and then we just added to that 2 standard deviations. So 2 times 9, that's supposed to be a 2. Sorry, I'm trying to draw with my mouse here. Now, when you count by standard deviations, that's technically a z-score. So instead of calling this number right here, the 17, it was calculated by taking x bar minus 1 standard deviation. Can't draw a subtract there. There we go. Excuse me. This would be here, no standard deviations from the mean, so that'd be a z-score. This is 1 standard deviation from the mean. This right here would be 2 standard deviations away from the mean. And over here, this would be -1 standard deviations from the mean, and -2. Standard deviations from the mean would be that 8 down there. So again, when we count how many standard deviations a number is from the mean, that's a z-score. So here we have z. So if somebody has an age of 35, they are 1 standard deviation away from the mean. All right, so let's save this and close it. Drop that in there. Just going to stick it over this one. Now, you might have read the 2 standard deviation rule, or the 95% rule. So that says for most data, about 95% of the values are within 2 standard deviations of the mean. So let's check that out. So let's go mean minus 2 standard deviations, and then the mean plus 2 standard deviations, and let's actually calculate them with the computer. So I just want to equals, take the mean, subtract 2 times the standard deviation, and then same thing here, equals the mean plus 2 times the standard deviation. All right, so I was saying it was about 8, which is close, and I was saying this one was about 44, which is close. And again, I was just doing pretty rounded calculations. So then up here, I want to count, well, how many of the numbers are within 2? So I'm going to put a note here next, within 2 STDs. Well, the lowest number is 16, which is above 7.5, and I want to get any number that's up to 44.5. So I'm just going to hold here and highlight. And there's a lot of numbers. Come on. Getting there. Okay, almost. Okay, so 44, yes, 45, no. All right, so how many do I have there? There is a command I could use called count, but instead I'm just going to go down to this summary button on the right and say, just give me the count here. So there's 415 numbers that I've highlighted there, and those are between 7.5 and 44.5. And I want to know how many is that out of the total to get a percentage. So 415. So here I'm going to do equals 415 divided by how many numbers are there. Well, for that, I'm going to use the count command for sure, for count parentheses, and then I'm just going to click on that column. So I want to count any number. So count will only count the numbers in the column. It's going to ignore age and blanks. All right, so I'm getting, as a percentage, about 93%. And again, the 95% rule that says about 95% of the data will be within 2 standard deviations of the mean. 93 is not too far away from 95%. And again, so 2 standard deviations to the left is somebody who's 7.5 years old. 2 standard deviations to the right of the mean would be about 44, 45 years old. And I found that there were 415 ages between 7.5 and 44.5. Out of the total number of numbers I have gives me a percentage. So again, we're checking that 95% rule for this set of data. And it's pretty close. All right, that's it on standard deviation for now. Take care, do good math.